these agents are incredibly intelligent, to use that word. They can reason, they can do really cool things, but even they're limited. Was it Jensen Huang or something said, soon we're going to have, communities of super geniuses, and eventually we're going to have hundreds of thousands of super geniuses in every data center. Well, the notion here is that the reason you have that is because some problems are just too big to be solved by even one super genius. What we need is the ability for these super geniuses to actually collaborate.
Welcome back, Eric. It's good to see you again. And
Likewise.
And today's topic is going to be a lot of fun because it addresses a topic that's been coming up significantly in everything we do. And we should start to put some shape on it and extend what you were talking about in the book. And it's all about memory. So today's podcast will be about memory and how to think about it, our models for memory in agentic systems. So how do we start such a thing, Eric? Is there an example you can think of that would kind of let us anchor this before we get into defining the types of memory?
Yeah. Well, let's use the typical example. This is
Okay.
typically what happens with, let's say 2, 3, or n number of agents in an ecosystem. So obviously a request comes in. It goes to the first agent, and that first agent would try and parse that request, and it would try and build a context. And it would go to the enterprise data systems, APIs, SQL, whatever the case may be, and try and assemble a working set of memory, that context that it can use to address the request. Now, sometimes it may need to collaborate with other agents. So first off, there's an individual conversation that one agent has, so conversational memory. Then there's shared conversations or shared memory. And then there's episodic, what happened yesterday. Now, the one I forgot to mention actually in that list is the static memory, the stuff that comes with the LLM, the training on the internet, the internet's knowledge base that is embedded in most modern LLMs today. So there's 6 of them, John. There's long-term enterprise data. There's context or working memory. There's static memory in the LLMs. There's conversational memory. What did I say? Shared conversational memory. What did my group of agents say? And then episodic. What did I say yesterday? What did I do yesterday? So those are the 6, John, that I think maybe we want to rally around. What are you thinking?
Okay. Well, so then we can finish early. I think we're done. I think we've just explained. Yeah. This makes sense to me because we work in the abstraction of agents all the time. I wonder if there's a way we can anchor this into something that we can talk about and have a conversation about for each of those types of memory, or do we construct one big example? What do you think? How do you talk about memory?
Well, let's do our bank account open example.
Okay, yes,
let's walk through that one just to recap. So we've a dramatically simplified bank account open. So we have bank account open for 4 agents that interact together. One that does an identity verification. Second one does, once that's accepted, we do a know your customer. Then we do the account open, maybe an initial deposit, and then we have an agent that notifies the customer that it's done and then sends regular statements. So those are the 4 agents. Maybe we should just walk through what happens as it does the request, and then talk about which various different types of memory that agent actually consumes. What do you think?
Yeah, no, great. Let's do step 1.
Okay. So I'll start and obviously add on to what I mentioned. So the very first thing that happens is an agent comes in, gets a request rather, an agent, the identity verification says, my name is John Miller and I want to open up a savings account. So what's the very first thing that agent actually does? Here's my thoughts, and then you tell me what you think. The very first thing it's going to do is it's going to parse that request and say, now I know what this person actually wants to do. I understand that perhaps the concepts that this request is addressing. I may actually understand a little bit about the policies I need to go get. But the very first thing that the agent does after it parses that request is it has to go get the data. It has to get enough information to address that request.
Okay, well, I want to go back a step and I want to say, how does it know? Okay, that funny question. How does it know what to do? And so let's talk about this. Agent number one. The name is ID Verify. Hi, ID Verify. I want to open a bank account. How does it know what to do with that statement? Teach me how it uses its memory to process that statement.
So the very first thing that it tries to do is it tries to create. Well, it parses that request, and then it tries to actually get the information that is relative and important to addressing that request. So the first
Right.
thing it does is it looks and says, among other things, um, let's figure out what concepts are actually here. So it may look
Yeah.
at, and I have a customer, and his name is
Yeah.
John Miller. So
Yeah.
now we actually have that. And for the identity verification agent, maybe that's the starting point for it. It probably needs a bunch more things, like it would probably look at policies and say, well, if you want to open up
But
a bank account, maybe I need to have a driver's license or something like that.
okay, so here's the trick. I was trying to get you to say, how does it know? Well, the answer is, let's say it wasn't trained on anything. It knows in its static memory, in what the LLM knows, it knows that there's a thing called a customer and right. And so without any special agentic superpowers, it knows because the LLM knows that the world is made up of customers that open bank accounts. So that's what I was trying to get you to use the static memory example. So that's
Well, I'm glad you
is that
pulled it out of me because
I know.
you're exactly correct. That I should have thought
Yeah,
this through a
well,
little bit
no,
better.
but this is why the concept of memory is worth talking about and simplifying so that we can all be on the same page. Because if we all understand how we're talking about it, we can do great things and build on top of these concepts. So I overteach. So okay, great. So the first thing it does is it understands that there's a request being made from a customer to verify its ID. What does it do? How does it use memory after that?
Well, now that it uses the static memory, the LLM based memory, to identify the fact that we have a customer, and I've been able to discern that it is John Miller. The first thing it's going to do is it's going to go and try and find information about John Miller. So that it can actually respond to that request, has at least the information to respond to it. So the very first thing that actually has to happen is it needs to go about, perhaps through a knowledge repository, needs to go and figure out, how can I get information about John Miller? And then also, what are the policies that dictate what identity verification documents, for example, that I may need? So along the way, it's actually going to an enterprise repository. It's using whatever indexing mechanism, a knowledge graph, etc., to go and get the information for John Miller. It would also go about getting from the enterprise repository, what are the policies that are relevant for this particular process or this particular request, and it would probably come back and say, hey, I have information about John Miller, and this process, this policy actually requires a driver's license for identity. So the combination there is, what we've done is the agent, specifically, has gone out, identified the relevant information from the enterprise data repositories. It has condensed it into a working set, the context, that it can actually use now to respond to the request.
Okay. And as part of that, I think there's a reasoning step. So it says, "Hey, this guy wants to be a customer." I reason that, "Hey, I wonder if he's already a customer." So I can check the long-term memory, right? That's where we said all the enterprise information is. Like, "Hey, maybe he already exists as a customer." And if he doesn't, maybe I can check the long-term memory to see, what am I supposed to do? Oh, sure, there's a rule that says I need to verify their identity. I better do that because my name is ID verified. Now, it does this reasoning, but it can't reason like, I haven't used the concept of short-term memory or context in explaining how reasoning works. And I think what you were doing was teaching us to think about this long term memory, this enterprise data has all been made available to the agent, but the agent doesn't have it in its working memory, so it has to go fetch it. And that process of filling up the short term memory, oh, this guy doesn't exist. That sort of logical reasoning based on what's in its working memory is part of the process that explains how memory systems work in this example. Is that now, did I get it right or fine tune what,
No, absolutely.
what
That
I'm
is
saying?
that
Yeah.
is that is exactly right. The best model, if you're into computers, this would resonate very quickly for you. But computers, like this example here, like the agent, has access to an entire disk drive. Today, that's terabytes. In an enterprise, that might be petabytes. And even a modern computer, if you're fortunate, you have a nice Mac Studio, maybe you have 128 gig of RAM, but that is still sounds large, but you may have petabytes of data. So what a computer does is it has virtual memory. And it has paging so they can actually identify what's on disk and put it into working memory. That's exactly the same model, although it's done a little differently. There's a little bit of different selection criteria around what you put in there, but the model is exactly the same. What I have is a large set of data, and I have to figure out what is the most relevant so I can get it into a useful working set. That is the fundamental thing that happens first.
Good. And that links back to the podcast we did when we talked about minimum viable context. We used the analogy of a hierarchical system of memory management that includes virtual memory management. And I love that you're anchoring it back to that because it follows very similarly to a CPU with its L1 cache, the L2 cache, you can see a hierarchy of memory systems ultimately to the cloud or, I'm glad that you're drawing that analogy because I think that analogy for how a CPU is fed information or memory is similar to how we're describing the use of working memory, what the agent sees, and its long-term memory, what the enterprise has that it can access. So, okay, so dude, so the ID verify agent, so he's figured out it's a new guy, and it calls. Then what does it do? Teaches more,
Sure.
great scholar.
Yeah, so what it might do, well, before we do that, let me just come
Yeah.
back. I want to talk a little bit about the static memory and why
Yes. Let's
there's
talk about that.
limitations. There may be limitations that so obviously the first inclination you would have is maybe as a result of being trained on the internet's knowledge, as it were, maybe this agent or the LM actually knows how to do a bank account open. Probably does. It knows a generic approach, but what it
Right.
doesn't know is the policies that are unique and specific to your business and the
Right.
operating region or jurisdiction you may be in. So the trick here is we want to actually blend and use as much of that knowledge in the LLM, its reasoning capability, but blend it with the unique capabilities and characteristics of your enterprise. And I think that's a crucial point. The trick is to find what that right balance is.
Yeah.
But so anyway, I just wanted to kind of highlight that. Now, the next step in the process is the identity verification agent. Let's say that it found John Miller, and you're trying to open up. You have many accounts, but now you're trying to open up a savings account. So the next step in the process is it understands that you got your driver's license. It needs to get your driver's license. Let's say you've provided that. It now has to hand off to another agent, the know your customer agent, where we're in banking terminology, simplistically, we're trying to understand the risk profile of John so that we can talk about him and guide him in decisions with his financials as necessary. So what we have now is two agents collaborating. We have a conversation. So the conversation, the handoff between agent A, the identity verification, agent B, the know your customer, there's a conversation. So that is part of the memory system. It is extremely short. It is extremely transient, but nevertheless, there may be, first off, obviously there's the first initiation, but there may be a back and forth between these two, and they may actually need to understand this within the scope of that conversation, what I said before, so I'm not asking for the same information repeatedly. So there's that conversational memory that's actually quite important, and I think that is that's the fourth one in the list. Again, we had long-term enterprise data, we had working memory or the context window, we had static, the LLM, and now we're talking about conversational memory, that dialogue that goes back and forth between an agent to address a particular request or hand off to another agent a particular set of elements of that request. Now, every once in a while, you may actually have other agents that may be involved in the discussion. So perhaps I need to actually engage a know your customer agent that is specific to, maybe you're living in California and California has particular rules. We have an agent that's an expert in rules around identity verification in Canada. But if I'm living in Germany or Europe, I may have different privacy requirements. I may have different capabilities that I need to actually look for, or different data that I need to look for. So maybe what I do is I engage a third agent. And now what we have is a shared conversation among multiple agents to actually address that request. So now what I have is shared memory. This is memory that's shared not just between two, but multiple agents. Think about it as Slack for agents, although there's the analogy wears thin pretty quickly, but what we have is this shared workspace where the agents can actually collaborate to address a bigger problem. So that's that next piece of the puzzle.
So when I hear what you just said, you said, well, the first agent, ID verify, talks to the second agent, know your customer, and says, hey, man, can you check them out? And what you're saying is that, what if this customer was in a jurisdiction that had some specialized rules? And so the KYC agent says, this might be a jurisdiction I don't know. Why don't I talk to my German agent or my, however you think about it, and say, hey, German agent, what is the jurisdictional la la la? So now, when you invite the German agent to talk to the other two agents or join the conversation, wouldn't it be nice if it already heard what was already said in the channel? Ergo, this conversational memory is important to share with other people, which is this shared memory that you're talking about, this shared conversation, or I've heard you call it a shared workspace. So I get it. They're talking or they're communicating, and as they invite other agents into that structure, they can share that workspace or that conversation. Is that right?
That is exactly right. And let me kind of elaborate on that.
Yeah.
There's a reason why things like Slack are so popular and powerful. Is it because what it lets you do is in real time interact to solve typically bigger problems. You're on
That's
Slack
right.
because two individuals have not been able to figure out a problem. Maybe I need to engage a third or a fourth or a fifth. So
Yes.
here's the thing, is these agents are incredibly intelligent, to use that word. They can reason, they can do really cool things, but even they're limited. So I
Right.
think, was it Jensen Huang or something said, soon we're going to have, communities of super geniuses, and eventually we're going to have hundreds of thousands of super geniuses in every data center. Well, the notion here is that the reason you have that is because some problems are just too big to be solved by even one super genius. What we need is the ability for these super geniuses to actually collaborate. So here's why we would use
Yeah.
Slack. When this problem gets bigger and more complex, we need to interact. That's what these shared workspaces actually do.
Yeah. And I just want to point out that we're not we're not taking a position on Jensen's view of the world. He's brilliant, and it might be true. And some of it might be marketing. I mean, a lot of the AI companies are accused of hyping the market. So, hey, we're not taking a position. We'd love to meet him, actually. And even without his vision, it's clear that conversations amongst agents in a workspace need to be shared. And one of the things that we do in Slack, not everybody knows this, which is odd, but you can pin things in Slack channels so that, hey, man, I'm going to pin the details of what we're doing so that the next guy that enters the Slack channel, if they know how to read a Slack channel, they'll check the pinned items or maybe even the description of the channel so that they can infer context. And when we think about agents and short term memory, they need to understand the context of the conversation, why it's happening, what are the pinned items, and how should they level up so that they can join the discourse without being the schmuck that hasn't read the pinned items, right? It's a frustration for me because a lot of people don't use, or in the olden days, they didn't use Slack. And so a lot of people still haven't learned the ways of working with Slack. And so I think it's a great analogy.
Yeah, well, here's the interesting thing about it. We, for all the right reasons, use an analogy of think of an agent as an employee or as a person. People love to communicate. And I would say that it is part of our nature to actually communicate. So here's another example of shared communications or shared conversations, social networks. When I'm having a conversation on, well, not myself, but maybe my wife or somebody I know has a conversation on Facebook, what we have is literally a list of, a list of who said what, and we can actually continue that dialogue. That shared conversation history is integral to social networks, just like it's integral to the power of Slack.
It's the concept of a conversation or a channel in either of those technologies. I like it.
Exactly. Yeah. So now I want to come back to one other thing is episodic memory.
So re-anchor us. So the ID verify has brought in the KYC, checked the German creds. Okay. So now where are we? Now yeah,
So imagine now we're still in the know your customer.
sure.
And let's say that this is the second time John's come into the bank to do a follow-up. So
Yeah.
now, the first time around, maybe you didn't have certain things, documents they needed, or you didn't have the answers to some of the questions. You're coming back to a week later, and you're coming back saying, hey, I've come back. I got the information you asked for. Here it is. What's the worst part of the experience if we did not remember what you said a week ago?
Yeah.
Well, that notion of remembering what happened a week ago is episodic memory.
That's
So
right.
so the ability to actually have not only real-time conversations, but continue where you left off is foundational to episodic memory. What did I say last week, and how is it relevant to what we're doing today? And this is quite frankly, a very simple but common example in a bank account open, where I come in the first time, I didn't know, I brought whatever I thought I needed some more. I come back a week later to complete the process. It will be a shame from a customer experience perspective if they forgot where I was in the process. Same thing for
Yeah.
agents.
Yeah, and what I love about this is we're really, in a lot of ways, describing what the early folks in conversational agent design were struggling with. How do you keep track of these things? And so we're not saying episodic memory is new. We're not saying workspace memory is new. We're just saying that if you want to think about and design systems of agents that interact, these are some of the building blocks of what you would need to consider when you're designing your system. And you don't have to think about it in such structured terms the way we're talking about it. But what I have found is that when we slowly describe this stuff, it helps people think about, well, okay, so maybe I don't have to do it the way I thought I did. Maybe I'll design my agents to operate differently. So,
Mhm.
okay, back to you on.
Yeah, so we come back to one word all the time in our conversations, and that is trust.
Ah, yes, sir.
So all this works if we trust the agent. If the agent trusts the other agent it's talking to, if the agent trusts the third party agent, perhaps, or that shared workspace is secure. So I want to come back to there's toy examples in a demo where you could easily set these things up. But in an enterprise, just like when you have Slack, there's security constraints around that. Although Slack may be relatively open, there's still, there's constraints around who can see what and who can participate in what channels. The basis for that, and this is the basis of our trust framework, John, is you need to have identity. Then you're going to layer on role-based access control, who can access which channels or who can access which agents. The fundamental trust framework we have, starting with identity and moving up there, is one of those things that constitute enterprise-grade memory that is required to actually function in the enterprise.
That's right. So it starts with each agent having an identity. Know your agent. What is it? What's its identity? What is it allowed? What's its authentication roles? Like, what's it allowed to see? Have you delegated responsibility to that agent so that it can read the documents about John? Or, like in that German agent, it just provides rules. Maybe it doesn't need to know about John and who is doing what. And so, if you use this way of thinking about access control in the same way you would with anything else in IT systems, you realize that role based access control at the level of memory is paramount. And it starts by understanding that identity is paramount. And so, what Eric is talking about and the thinking that you've put to paper is that that was the starting point, and we are still designing how to do certain of these things, like RBAC in long-term memory, non-trivial. RBAC and RBAC is role-based access control. In any of these types of memory is, I wouldn't say it's unsolved, but there's no common patterns that are effective and being promoted around the world. This is one of the areas where we're going to see a lot of change. And I'm actually doing a podcast for DAMA LA on role based access control for agents. But anyway, go
No,
ahead.
but here's the cool thing about it, and I emphasize this discussion or this thing you mentioned around DAMA LA. We have the opportunity to learn from others. We need to stand on the shoulders of giants. So whether it's, like you said, identity is not necessarily simple to solve, but it's a solved problem. We know,
Right.
we know there should be an identity book of record and there's protocols to actually engage it. Same thing for role-based access control. If you're going into a database, yes, there may be some differences between the various different products, but we know how to do that. If you're talking about APIs, OAuth 2, which is loosely speaking, gives you a role-based access control. Those are things that we would know. We probably want to think about, if we want to do problem diagnosis, maybe we want to capture the information that in those conversations. So but maybe not everybody should see it. Maybe we should scrub those logs of credit card numbers or whatever may come up in the discussion. Here's the thing, and we come back to this time and time again, is there are known practices that with some tweaking, we should be able to adopt. There's probably no good reason to start from ground zero when you're thinking about agent memory or related agent trust or agent identity or agent role-based access control, John.
Yeah. And that was the topic last week or the last couple of weeks for the RSA conference that was happening here in San Francisco. There were signs, billboards all over the streets about access and memory, and it is an unsolved problem. I I do want to point out that we've already solved redaction as well, because anybody that was listening to us would say, "Hey, boys, we've solved redaction." What we haven't solved is some of the more complicated multiplayer scenarios where uh, there is federated identity, and how do you think about RBAC? And like I said, there are groups everywhere doing this work. And I think what we find in this podcast is we are reintroduced, because we've experienced them in our careers, reintroduced to all of these domains of expertise who are working the problem from their perspective. So I'm glad you called that out, the security professionals and that data management association I'm part of, DAMA International. They have a chapter in Los Angeles that I'm a part of, and also the one in San Francisco. And what I love about that group, shout out to those guys, is that their whole premise is on being professionals, certified professionals in data management practices. Well, if you want to talk to somebody who knows about data governance and knows how to think about a lot of these issues related to data and memory, there's a lot of smart people in the DAMA organizations too. So shout out to those guys. We're at time. I know we have a hard out. So, Eric, dude, again, I've enjoyed our conversation. Anything you want to add?
No, I think that's a wrap, John. Great discussion. Great insights, my friend.
Okay. Like and subscribe if you like it and tell your friends about our podcast. Thank you, everyone. Bye for now.